Good day everyone, welcome to Math with Teacher Justin. On today's topic, we're going to solve word problems involving combined variations.
Okay, let's have our first word problem on combined variation. So the number of girls varied directly as the number of boys and inversely as the number of teachers. When there were 50 girls, there were 20 teachers and 10 boys. How many boys were there when there were 10 girls and 100 teachers? Let's identify our variables present in this word problem. So, our variables are the number of girls, the number of boys, and the number of teachers. So, let's have our representation for each variable. So, our representation, let G be equal to the number of girls. Let B be equal to the number of boys, and let T be equal to the number of teachers. Now, our next step is for us to translate the word problem into an equation. Now, in translating a variation problem into an equation, let's look at our keywords. So, since we use the word directly or varied directly or varies directly and inversely in our word problem, we have a combined variation. When we say combined variation, we're dealing with two types of variation in one word problem. So, the number of girls varied directly as the number of boys and inversely as the number of teachers. So, we can translate that as the number of girls, which is G, is equal to the constant variation times the number of boys, since we use the word varied directly, divided by the number of teachers, since we use the word inversely as the number of teachers. So this will be the equation that we're going to use in order for us to solve our word problem. Let's proceed to our third step, which is solution. In solving this word problem, we must first find the constant variation using our first set of given. So using the equation, G is equal to KB all over T, we can now substitute the first set of number of girls, the number of teachers, and the number of boys. So substituting that, we will have 50 is equal to the constant variation times 10, the number of boys, all over 20, the number of teachers. So simplifying 10 over 20, we will get 1/2. Let's multiply both sides by 2 to isolate the constant variation. So 2 times 50 is equal to the constant variation. So our constant variation is equal to 100. Now, using our constant variation, we can now solve for the number of boys when there were 10 girls and 100 teachers. Using the same equation, we can now substitute the new value or the new number of girls and the new number of teachers. So we have 10 is equal to 100 times B, the number of boys, all over 100. Simplifying that, we will have 10 is equal to B, which is our final answer. The number of boys when there were 10 girls and 100 teachers, it is equal to 10. Let's have another word problem on combined variation. The number of horses varied directly as the number of goats and inversely as the number of pigs squared. When the barnyard contained 5 horses, there were 4 pigs and only 2 goats. How many goats went with 6 pigs and 10 horses? We need to identify the variable present in this word problem. So the variable that is present in our word problem are the following: the number of horses, the number of goats, and the number of pigs. Let's have a representation for each variable. So, let H be equal to the number of horses, let G be equal to the number of goats, and let P be equal to the number of pigs. And after setting our representation, it's time for us to translate our word problem to an equation. Now, observing our word problem, we use the word varied directly and inversely. So, since we use two types of variation, we will have a combined variation. So, we can translate this as the number of horses is equal to the constant variation times the number of goats divided by the number of pigs squared. Then after that, we can now solve. Using the same equation, we can now find our constant variation using the first set of our given, which is 5 horses, 4 pigs, and 2 goats. Using that, we can find our constant variation by substituting that to our equation. So we have 5 is equal to the constant variation times 2 all over 4 squared. Simplifying 4 squared, we will get 5 is equal to the constant variation times 2 all over 16. Simplifying that, we will have 5 is equal to k divided by 8. Multiply both sides by 8, we will have our constant variation, which is equal to 40. Now that we have our constant variation, we can now solve for the number of goats with 6 pigs and 10 horses. Using the same equation, we can substitute our constant variation, the number of pigs, and the number of horses. The new number of pigs and the new number of horses. So applying substitution, we have 10. The number of horses is equal to the constant variation 40 times the number of goats, which is the one we're looking for, divided by the number of pigs being squared. Okay, simplifying that, we have 10 is equal to 40 g all over 36. Let's simplify 40 over 36. We will get 10 is equal to 10g all over 9. Now, if you want to eliminate a fraction, we can multiply both sides by the reciprocal of that fraction. So, to eliminate 10 over 9, let's multiply both sides by 9 over 10. Simplifying that, we will get the number of goats, which is equal to 9. And that will be our final answer. Alright, let's have our last word problem on combined variation. The volume of gas varies directly as the temperature and inversely as the pressure. If the volume is 260 cubic centimeters when the temperature is 390 degrees and the pressure is 18 pounds per square centimeter, what is the volume when the temperature is 380 degrees and the pressure is 24 pounds per square centimeters? So in order for us to solve this word problem, we need to identify the variable present in our word problem. So the variables that are present in this word problems are the following: or the volume of gas, the temperature, and the pressure. So let's have our representation. So let V be equal to the volume of gas, let T be equal to the temperature, and let P be equal to the pressure. Now our second step will be translating the word problem into an equation. So since we use the word varies directly and inversely, we will have a combined variation. So we can translate this as the volume of gas be equal to the constant variation times the temperature all over the pressure. Third step, let's proceed to our solution. So in order for us to solve this, we need to find our constant variation. So using our equation, let's substitute the first set of our given to get the constant variation. So we will have 260, that is the volume of the gas, is equal to the constant variation times 390, which is the temperature of our, and the temperature, which is equal to the temperature, divided by 18, which is our pressure. Simplifying, we will have 65 over 3. Now to eliminate a fraction, we must multiply both sides by the reciprocal of that fraction. The reciprocal of 65 over 3 is 3 over 65. So multiplying both sides by 3 over 65, we will get our constant variation, which is equal to 12. Now that we have the constant variation, we can now use this to get the volume of the gas when the temperature is 380 and the pressure is 24 pounds per square centimeters. So using the same formula or using the same equation, substitute our new value of the temperature and the pressure and the constant variation. So we will have V, the volume, is equal to 12 times 380 all over 24. So simplifying 12 and 24, we will get 1/2. And then simplifying this, 380 divided by 2, we will get a volume of 190 cubic centimeters.
Now that you already know how to solve word problems involving combined variation, it is your turn to try it. Please click the link in our description box below in order for you to test your skills. That's it for today. Again, I'm Teacher Justin. Goodbye, God bless, and stay safe. See you on my next video.